Good morning, everyone. Thank you for coming. This has really been an amazing experience to work with these talks and to think with everyone about these really important and very difficult issues. So today, The Blind Spot is actually the name of a book that the three of us are actually writing. We're just starting the project. And the idea is to sort of think about physics and science and mind in a very different way. And Evan's beautiful talk yesterday laid the groundwork for some of the things I'm going to talk about. So The Blind Spot you can pre-order now. But I'm very excited about it. So the subtitle, though, is Time and Experience. I want to talk about how physics different ways of approaching the ideas of particularly ultimate reality in science. So this is a book I have. I remember finding it, when I was there. I think it was maybe not a graduate student, but I just love the title. Like, what an amazing title: Science and Ultimate Reality. Right? Reverb on that, right? So the idea, of course, among physicists, many of us as physicists go into physics because we want to know what ultimate reality is, right? Physicists, we think what we're doing is we want to provide an account for nature at its deepest level, its basal structure. I'm going to come back to that a bunch of times. And clearly this is a quasi-religious, if not religious, impulse. I mean, of course, most physicists say, oh no, it has nothing to do with religion. But where does it originate from to know the basal, structure of reality? So, I want to talk about the way physicists we've been thinking we're doing this, and the biases that maybe come into it, and the trouble that comes from it, and think about other ways of looking at it, this question of ultimate reality. So, I just want to talk about physics and philosophy for a moment. They have this long and sometimes contentious history, particularly more recently. I mean, back in the old days, 100 or 200 years ago, even 100 years ago, many physicists were well versed in philosophy. You go back far enough, there were no physicists, there were natural philosophers. But recent comments by some physicists have sort of illustrated this problem. I'm not going to tell you who these people are. You can figure it out for yourself. It's not that there can't be other philosophical subjects, plenty of stuff for the philosophers to do, but the frontier of the physical sciences did not appear to be among them. And then here's a quote by a famous physicist: "Philosophy is dead." Right? And this, not only is this silly, but it also, for a lot of these, some of these physicists are working at these frontiers of physics, where these issues of time and space are very malleable, and so that they make these amazing claims about philosophy is not even important, and then they make these incredibly naive philosophical statements that they don't even recognize as being philosophy. So it's a strange position that we're in the field. So I want to ask, what role does philosophy play in physics, and what role can philosophy play in physics? And by this I mean, philosophy quite generally. I'm going to actually expand beyond the sort of the domains that even physicists who think about philosophy think about philosophy. So in particular, what I mean is, what kind of philosophy are we talking about? And can it be a philosophy that also engages in some different way in the discussion of mind? Okay, so first let's just start off and do a little brief review of what we mean by ultimate reality and what physicists think they mean by ultimate reality. So these are what we call the standard model. There's actually two standard models we need to come up with. Think about. The first is the standard model of space and time, or space-time. This is general relativity, Einstein's groundbreaking work in from the first two decades of the 20th century. And they told us that essentially, matter or space-time is this manifold, this flexible continuum, which is distorted by the presence of matter-energy. So you've got space-time and matter-energy, and those they're dual to each other in some sense. And so here's this image of the Earth orbiting around a black hole, and you see it's interesting, we were talking about how images get distorted or how we perceive images. The image of the Earth gets distorted because the light from the reflecting off the planet has to travel through space-time, which is itself bent. So this idea that this was a radical idea that space-time, so the framework of reality is kind of like a stretchable fabric. So that is the basis of everything we use when we understand black holes, when we understand the cosmology. Our basic understanding of space and time is the standard model of general relativity. Now, what is in space and time? Well, it's stuff, right? It's matter. Now we know that matter, we should really think of it as matter and energy. Well, what is that? Well, so there's a standard model of particle physics, which is a complete census, almost, of normal matter and the forces that it operates under. So we've got quarks, and there are 6 different kinds of quarks, and we've got leptons, and there are 6 different kinds of leptons, and there are 4 different kinds of forces by which these particles will respond. Okay? And that pretty much is it. And it's a beautiful theory. It is, it is magisterial in its account for the world. Now there are some problems with it in the sense that we know that there's now dark matter. We don't know what dark matter is, but this really, we don't want to understate what an important achievement this was. So we have a standard model for matter. We have a standard model for and the forces between matter, different types of matter, and we have a standard model for space and time, which is the container or the stage on which the drama of this matter will play. Okay. So the interesting thing about this was that pretty much the last piece of the standard model was put into place in 1964. Okay, that was the Higgs boson, right? That was the prediction of the Higgs boson was made in a series of 3 papers in 1964. And since then, people have been searching for what comes after the standard model, because the standard model doesn't embrace everything. In particular, there's about 20 constants that go into the standard model, and this is very much more Marcello's field than mine, but there are these 20 constants which you have to sort of put in. You make measurements and you get these numbers and you stick them into the models. And the question is, well, what determined those numbers? So people have always thought that there's something deeper than the standard model. And so the idea that for decades now has been supersymmetry. The idea that every particle that we know of has a symmetric pair in terms of, when we talked about quarks and leptons, every quark has a symmetric lepton-like pair. And so people put enormous amount of energy into this idea of supersymmetry. This was really thought to be the next step beyond the standard model. And in particular, it's all of these new particles that it predicts. It was thought to be that was what dark matter was. I'm not going to go into what dark matter, you guys probably heard about it. We can come back to it later if people have questions. So this was the idea, that this was going to be where we were going to go beyond the standard model. It was going to be awesome. There's thousands of papers written on this. And then the other, that going even further, was going to be, well, how do we unify these 2 great standard models that we have of space-time via general relativity and matter via the standard model? And that was the idea of unifying the 2 via quantum gravity. Because here's the thing. The particle physics models are all fully quantum. We know that the world at the smallest scale breaks up into discrete packages, which is what quantum means. But space-time, our theory of general relativity, is not a quantum theory. It's a classical theory. It treats this manifold or flexible fabric of space as being a continuum. So we know that at some point we have to have gravity become a quantum theory. So people have been looking for decades now for a theory of quantum gravity where at the smallest scales, which is like the Planck length, 10 to the minus 44th of a meter, that space-time itself would become granular. So people have been looking for this. This is our holy grail. And in some sense, the answer is we don't have it. We failed, right? On some level. I want to be careful, I don't want to be too strong about the idea of failure, but on some level we have. There is, from data, we now have the Large Hadron Collider. It's been running for 3 or 4 years. And that we have been looking for supersymmetry in there. And the simplest model of supersymmetry, you can make more complex models, but in some sense, the point of supersymmetry was for it to be simple, has not shown up. So you can see up there that Scientific American cover the crisis in physics. Here, the Scientific American article in particular was talking about the failure to find supersymmetry in the LHC. And also, we don't have a theory of quantum gravity. In fact, most of our theories of the most popular theories of quantum gravity have wandered off into these strange places that really, as some people would say, that just fictions have created fictions. For example, there's string theory, which you guys have all heard about. The only way string theory works is if you have extra spatial dimensions that curl up on themselves like straws. There's no evidence at all for these extra dimensions. Because of where string theory has gone, it has embraced an idea called the multiverse, which is that out of the Big Bang you got not one universe, but an infinite number of universes. There's lots of work being done on this. It too, there's not a single shred of evidence for this, and yet there's a huge amount of work going on. And because of that, people, Marcello and I included, this is a piece we did for the New York Times last year, but people have really pushing back again on this idea of a crisis in physics, that these things, as Joseph Silk and George Ellis wrote in this piece for Nature, said that, this is like physics, and it's got elements of physics and philosophy and math, but none of them being done well, right? So that's really in some sense that physics at its frontiers has lost its way. So it's because of that now some people are pushing back, and they're pushing back in a way that's relevant for what we want to talk about this morning. So there's this book, which I liked a lot, or at least pieces of it, by Roberto Unger and Lee Smolin. Unger is a philosopher of law, and Smolin is a physicist. And what's important to me about this book is that they were very clear about the fact that the problem with physics is that it had mistaken its metaphysical biases for actual physics. So let's just read this quote. It's important to distinguish what science has actually found out about the world, and that's going to be important for us, from the metaphysical commitments for which the findings of science are often mistaken. And I think that's a really important point to hold in your mind, because in these debates that often you see happening, and a part of this is also what I was talking about, the physicists who just make these ridiculous philosophical statements, not knowing that they are philosophical statements, is embraced by that quote. So what is the metaphysical commitment that many physicists have? It can be basically called reductionism and materialism, or physicalism. Physicalism is a sort of more sophisticated version of this. And I'm going to stay with materialism for now. And it basically says that everything we see is composed of smaller parts. Particles, fields, or structures. Smaller can also mean more basic in some sense. So there are, and if you go down far enough, you will find the ultimate smaller parts, the ultimate structures upon which everything is based. And once you find the ultimate laws of those ultimate parts, that's what I mean by a basal structure, right? It is the absolute ground of reality. Then you're done in some sense. No new emergent laws occur at higher levels of structure. You don't need any laws for anything else, right? Evolution ultimately is down in those basal laws, right? Or those basal structures. So the world is nothing but atoms. And for our things we're talking about, mind is nothing but neurons, which is nothing but atoms, okay? And this is still, I would say, a dominant kind of background. And I'm a lapsed materialist reductionist, right? It's clear why there's something very attractive about this. But as we're going to talk about, ultimately it becomes a dream. Both an aspirational dream, but it's a dream that you have to wake up from. That's kind of what we're arguing. That is, it's a dream as in terms of an illusion. Because, not only is it wrong, probably, actually it's not this doesn't lead us to the basal structure, but it also has created a mess of the world, right? Reductionism basically says the world is dead. It's just atoms, the atoms are dead, and all the illusion of richness, of your feelings of love and joy, yeah, fine. Really all there is just neurons, okay? So get over it. Along with that comes this idea of scientism, that ultimately the only truths that matter are scientific truths, right? So, you really enjoyed that, performance of Hamlet last night, but still that was just in your neurons. There was no actual truth there, right? Maybe there's some truth up here relative to sociology, but who cares about that, right? Because really, the basal structure is reality. And, I would argue this would be a longer argument, but that's what leads to this sort of devastation of the world, right? What is sadder than a parking lot of a big box store that has closed, right? And there's so many ways, there's millions of ways to describe why this represents the mess we're in, right? We're pushing the planet over into new territory. Again, the planet's going to be fine. It's going to be very bad for us, right? So, but this sort of I think this is representative of what I mean by the mess we're in. So it's both. The question here is both about the actual truth of what the world is and what we are, but it also has these enormous consequences. This mistake has these, or the blind spot has enormous consequences. So now I want to tell you to illustrate I want to illustrate actually the moment in some sense when this began, when this rift between philosophy and physics began. By philosophy, I mean this deeper, broader philosophy, not kind of a reductionist philosophy. And it was this amazing debate between the philosopher Henri Bergson and Einstein. And it happened almost by mistake in 1922. Bergson was the most famous intellectual in the world, right, at the time. Hardly anybody even knows his name. My son, it's funny, I just got an email from my son, who just discovered him by mistake, thinking who is this guy? Henri Bergson, oh my God! At the time, when this debate happened, Bergson was way more famous than Einstein. Okay, nobody had heard of Einstein compared to Bergson. And what happened is that Einstein was in Paris talking about the theory of relativity. Bergson had spent a lot of time talking about time. That was a central issue to him. And the two got into into this brief debate that ended up flowing. The debate continued among both themselves and their proxies. And in some sense, it was the moment when scientific knowledge became seen as being superior over all other forms of human knowledge and human activity. So that's this great book. I really recommend this book where Jamil Canales charts this out. So for Bergson, his point was that there's more to time than science can embrace. Time is about, he used the word duration. It's about lived experience, and it is imperfectly grasped by science. Okay? So for him, relativity, which was this emerging, paradigm about looking at, as a way of accounting for the world, relativity is a theory of clocks, not of time, right? It's about what clocks are going to read as people are moving at different speeds relative to each other. In Einstein's debate, when you can imagine this was going to, roil some, that the time of the philosopher does not exist, right? That this thing you're talking about duration and everything, it is just psychological time, right? It's just about your perceptions, and your perceptions are just neurons, your neurons are just atoms, end of story. Okay? But here's my question, this is what I want to spend the rest of the time talking about. Are clocks enough? Independent of Bergson's solution, was his question correct? Because I don't know that much about Bergson, so I can't really speak to it. But the question he was asking is near and dear to my heart. So I want to revisit for a little while that issue of time in philosophy and its consequences, and then talk about sort of how it touches on some of the other issues we've raised. Marcel, how much time do I have? I just didn't know when I started.
Yeah, 20 minutes.
20 minutes, okay, good. There's a usual way that philosophers and physicists will talk about time. It's usually what's called analytic philosophy, things called the McTaggart A and B series about how you parse, last week versus the future. That's not what I'm interested in. What I'm interested in is, luckily, because of the beautiful talk that Evan gave yesterday, I don't have to go into this in much detail, but you have to understand phenomenology. What Evan was talking about is like nobody in physics knows what this is, right? If I stood in front of physicists and started talking about the philosophy of time, they'd expect me to talk about the McTaggart A and B series, right? Very well known. Most of them wouldn't even know what that is. But if I talk about phenomenology, I'd be like, what? And yet, so there's this, entire branch, continental philosophy, which just never appears in the discussion of philosophy and science. And that's a bummer because there's really a lot there for us if we can figure out how to make the leap. So, we've already talked about this yesterday, I don't have to go into it in great detail. People like Husserl, Heidegger, Merleau-Ponty were articulating this very different approach, and they were interested in the verb to be. Right, which I think is very much at the root of what we're trying to ask about. And what they were attempting was to develop methods for exploring the act of being a subject, right? So subjectivity in physics is really a bad word, right? You want to eliminate subjectivity as much as possible. It's not, it's an illusion, it's not important to us. But for phenomenology, it's the central question. What does it mean to be a subject? What is being? Right? So this is one definition which maybe isn't so great. Phenomenology attempts to create conditions for the objective study of topics usually regarded as subjective. So here's my big claim, and here's the big claim, that I'm willing to go to my colleague physicists and have them throw eggs at me for it, that experience is irreducible. And to me, that's what makes phenomenology so exciting, right? It says that, look, the thing that is basal, the true basal structure is your experience. Everything happens within this horizon we talked about yesterday. And any attempt to deny that is to create sort of fantasies for yourself, or fictions. They may be useful fictions, but the true basal structure is experience, and you can't break it up into smaller parts. It has to be taken as a whole. I love that quote about Husserl's idea that the world is one, but not in a way that it could be two. Right? I think that perfectly expresses what we're trying to do. And this is what I think is at the root of contemplative practice is the non-duality. Whatever that means, is where you're shooting for. So the important thing here is the primacy of perspective. For me, the phenomenological stance is useful because it entails, there's two things that are important. The first is you just can't escape from perspective, right? You're just going to live your whole life looking out through your eyes. You always have a perspective. And then two, that experience is a totality. It's a unity, again, this idea, it's one that cannot be imagined as two. And you can only ignore it for so long, right? You can ignore it for a while because you can do useful things by ignoring it. But if, again, you're interested in ultimate reality, if you're interested in the basal structures, then, at some point you're going to have to deal with it. And the problem with dealing with it is that it is a kind of blind spot for us. It is, the blind spot is the place where the optic nerve is, and it is, what is it? It's that which you cannot see, which allows seeing. An experience is the same kind of thing. That it's very hard to look directly at, but you can't look directly at anything without it. So what does this have to do with time? Well, we want to avoid the quantitative view of time as a container. That's very much the view of Einstein, right? The view of general relativity is that there is this, we call it the block universe of space-time entire, where all events already occur. Next Tuesday already exists in space-time. Whereas for Husserl and Heidegger, they were trying to wrap their minds around this immediacy, this unity. So Husserl talked about the life world, which Evan beautifully articulated. I was a big fan of Heidegger when I was in college. I did like a year of study of Sein and Zeit. And I loved his idea of Dasein, their being, the being that has a there, right? So that time is the lit up place for us, right? So recognizing that this unitary life world or Dasein as a prerequisite, it's where you have to start in order to get the Newtonian scientific notion of time as discrete or atomistic moments measured by clocks. I mean, that's what you have to recognize, is that you can't do the Newtonian or Einsteinian thing without already being Dasein. As Husserl says, natural objects must be experienced before any theorizing about them can occur. So this points to this idea of what the objective frame. Physicists, what we want, is to read the mind of God. We want to think God's thoughts. We want the objective view. But I think what this really points to is that you cannot have a view from nowhere. Okay, so I want to speak for a few minutes about the very idea of objectivity upon which science is based. So, experience and Dasein, experience and their being. So, reductionism versus non-reductionism leads us to, so let's first consider what the reductionist view is, right? So, here's a picture of a person viewing a boat, the boat's moving on a river, the river's moving. This is a typical way we analyze motion as physicists, right? So, the reductionist view says that human experience is situated within physics and science, right? There's the objective world with its objective laws, and human experience and the brain is just something that is, situated within that objective world, right? And psychological time is just happening inside that guy's head. But a non-reductionist account begins before these distinctions and systemizations occur. Again, this is why contemplative practice is so interesting in the idea of non-duality. So that's what it looks like, right? Compare that to this in some sense. How do I represent that, right? How do I represent this non-dual? And that's, I think, the interesting question we're going to have to approach as we try to really dig into this. Now, the interesting thing about non-reduction, and this is a word that Heidegger uses a lot, is circumspection. Remember, so part of the problem with the objective reality is I say, okay, everyone right now, I want you to imagine objective reality, right? So what are you doing, right? You're probably thinking of yourself maybe like floating above a planet or something, you're looking down on it, right? But you're always looking down on something. You're still just a disembodied head now. It's not your head looking through, it's a disembodied, it's God's head. But it's still a perspective, right? Because we don't even know what else to do. And so what Heidegger was articulating was this idea of circumspection. Somehow to do this, we're going to have to learn how to see, the world from a 360 or 4 pi steradian, view. And I love these kind of these images because they sort of very nicely demonstrate what we're talking about. And I think it's a great image of the horizon, right? Because here, where's the horizon? The horizon's there, but it's wrapped back on itself. And that's this question of the horizon is everything. You can't get out of your horizon. Right? There's just no way to experience, it's not even just to experience the world. The world is the horizon, right? So it's not like there's some outside, that's like the point I'm making about trying to imagine the objective reality. When you do it, you're really just imagining yourself with another horizon, okay? So circumspection, trying to approach circumspection in some way, which I think is what contemplative practice is one thing that trains us for, is an important characteristic of this. Is just another example of it. I like this one because the tree and the horizon of the green grass, because part of the mess we're in is we've taken ourselves out of the picture. We forgot that we're part of life, right? We're part of the biosphere. And that has, there's a way, so this thing cascades either up or down all the way to issues of the Anthropocene and climate change. I thought it would be worthwhile to mention just for a moment the way horizons appear, because we talked a lot about horizons, particularly yesterday, how horizons appear in physics. So basically, and this is interesting to unpack, horizons are reflected in physics because of relativity, and they're really about locality. Because the speed of light is finite, what that means is that there's only so much of the world you ever get to know. There's only so much of the world that I am responding to now, and there's only so much of the world during my entire life, because my life is finite, that I'll ever get to experience, both experience directly or get signals from. So we talk about light cones. So this is you here, and these are two light beams heading into the future. These are two light beams coming from the past. And pretty much at this moment, the only parts of reality you know about are these down here. Everything over here right now is called elsewhere. And there's just, at this moment, it is beyond your horizon. You don't know anything that's going on out there. Now, of course, again, the idea of the horizon moves. As you move along in time, when you're up here in time, then you will be able to get signals from out there. Okay, so this horizon is constantly changing. Okay, so we can come back to that if people are interested. And then, of course, cosmically, we have a horizon. We only get 13.7 billion light years or so. It's actually more than that because of the expansion. I can never sort of work that out. But there's basically only so much of the universe that we get any signals from. So there's a cosmic horizon that we can't see past. So it's interesting to sort of, how can you parse this? How can we pull these into our discussions? Okay, so now what I want to do is I want to turn this question about physics and experience on its head, right? So the usual question that we ask is, how do we situate experience within physics? How do I articulate the physics of neurons, right, in order to explain, my experience as just, computing with meat, basically, within a universe of absolute laws, Basically, the usual idea is I start with the basal structures, right, of physics, and I'm going to work my way all the way up to this computing engine in my head. But the question I want to ask, and I don't know how to do it yet, but this is what I think this conference and our time here together is, how do we situate physics within the unity of experience? The experience is the basal structure, and physics comes afterwards, right? Physics comes, it's the structure that we build. So let's unpack that a little bit. Well, and also, where would we go if we actually could do that? So this is really an attempt to reimagine the metaphysics of scientific practice. And again, this brings us back to objectivity. And so the question here is, so this is from this great book by Thomas Nagel, The View from Nowhere. And the whole history of physics is a wish for a unified conception of the world, where human beings just don't matter. Like, it's an objective view, there's nothing about subjectivity in it. His whole point was like, you can't take the subject out of it. But he says, if we can't achieve this unity in a form that eliminates distinct, irreducible, individual perspectives, may we inquire to what extent can it be achieved if we admit them? That is the task ahead. That's the task. I don't know what the answer is, but I think that's the interesting part. So this idea, we have to give up on the idea of the objective frame. It is, we don't have to scorn it. It is highly useful. It is an amazing story, but it is just that. It is a story, and it is unexperienced and unexperientiable, right? Or unexperienceable. And that's really the important thing. It is a fiction. And so at some point, as we ask these ultimate questions, we have to wake up from the dream. We have to wake up from this story that we've been telling ourselves and try and really encounter the basal structure with this experience and to reanimate the world in some sense, to put ourselves back in the world. So one of the reasons, or one of the ways this occurs, this forgetting, one of the reasons we have such a hard time with this is because you have to see it, you have to look at how science actually operates. And there's this beautiful piece by Michel Bitbol, who's a philosopher of science, about how objective knowledge is created as a process of extracting invariance from experience. So I just want to read this whole quote to you, because it really tells sort of like, why, this is really an account of the blind spot. The creators of objective knowledge become so impressed by its efficacy that they tend to forget or minimize that conscious experience is its starting point and its permanent requirement. They tend to forget or to minimize the long historical process by which the contents of experience have been carefully selected, differentiated, and here's the key word, impoverished, right? So as to discard their personal parochial components and to distillate their universal fraction as a structure. So to do science, to get temperature right? The temperature of thermodynamics out of our experiences of like, oh, today's hot, tomorrow's gonna be cold. You have to go through this long process, and in the process, it's very useful for building, a heater, but you impoverish the world, right? And your language for understanding your experience as a embodied, embedded being gets impoverished. So this leads us back now to the idea, but now here's where we come back to mind. So there's David Chalmers, famously came up with the idea of the hard problem associated with consciousness, and that there are easy problems. These are clearly not easy problems, but there are easy problems, such as the neurodynamics of vision, right? We saw incredibly hard problem, and actually there's layers there that may really reveal very important things that we heard today. But the hard problem is, why do we have experience at all? Like, what is the act of being a subject? And so then they talk about qualia, as we talked about these internal and subjective components of sense perceptions, and those are incredibly important for beginning to sort of get a grip on what is occurring in the dynamics of the brain-mind interface. But even to talk of the word consciousness and qualia on this philosophical level are themselves attempts to freeze out structural invariance, right? Consciousness is not a thing. Right? Consciousness is not a thing in a box. Like, that's what we're good at in science. We're good at putting things in boxes and putting them on a table and poking them and seeing what happens, right? But consciousness is not like that. In fact, I don't even like the word consciousness. Experience is what we're talking about, right? Because experience, when you talk about experience, it totally changes the frame. It totally changes, sort of the flavor of what you're talking about. And the qualia, even before you have a qualia of redness, there is, and Evan talked about this before, this is one of the most important words I think that comes out of Buddhism, or at least the contemplative practice, is luminosity. The world has to be luminous, to you, or you are the luminosity. That's what I love about the word Dasein. You have to have a there before you can have a qualia appearing into there. And that is, for me, the fundamental mystery. And that's the basal structure that I'm most interested in. So in that way, experience, is time. Okay? Experience and time, in some sense, are almost the same thing, which is why, so many books on this are, have the word time in them. So, Heidegger's masterwork, Sein und Zeit, was being in time. Okay? So back to my big claim. Experience is irreducible. Time, in Bergson's sense, lies, in some sense, at the root of the hard problem. And so in this way, there is absolutely a time which is not the physicist's time, which is not Einstein's relativistic time. And who knows where we'd go if we actually, as physicists, if we actually embrace this, So now let me just touch briefly on the end about the ideas of, bringing contemplative practice into it. So the philosophical lineage that begins with Plato is, for me, lots of great things in there, but it's really introspectively impoverished. It is very outwardly focused. It's always about the world and its appearances and what's actually out there. And I think it's because maybe, because of, the West was basically monotheistic. All the religions were monotheistic, which was that there was this super being, and you really wanted, the super being was the objective ontological framework. I wanted to read God's thoughts because God had set up the stage in which I was living. So, in Western philosophy, you get lots of people talking about the mind, but there was never a craft or a technique for actually deeply looking at the mind. So, one of the things that's very funny about, so many of the studies in psychology, et cetera, that happen is that they're done on college students, who probably are showing up stoned out of their mind from the night before. And, in general, when you're a college student, your mind is not particularly focused, right? So, how can we talk about the mind when the people were having, it's the idea of when I talk to physicists about this, it's like somebody were to walk into a physics class, an intro physics class, and go, whatever, walk out, and then, want to talk about physics for the rest of their lives. There's a certain way in which we can't develop methods of stabilizing attention. How can we know what it is we're talking about when we talk about the mind? So, clearly the civilizations of India and China, et cetera, did not have this problem, there are other problems, but this idea of the internal representations, internal stabilizing attention, distinguishing internal states was very important. Now, I want to be careful here because these waters are poisoned, okay? We definitely need to enlarge the library that we draw from, so people like Asanga, Nagarjuna, Dogen, because these cultures had thousands of years of, sort of looking at these questions of the nuances of experience. They have, I call it the many words for snow effect, right? There's just so much more. The language there is not impoverished. There's many subtleties about thinking about attention and experience. But the problem is that we have to overcome this legacy left over from quantum Buddhism, which is sort of the New Age kind of groovy Taoist physics sort of thing. And there's just a huge problem. You notice I'm not, I'm going to talk about mind, but I'm not even at all mentioning quantum mechanics, right? They're very interesting questions about quantum mechanics and mind. But, the problem is it just like for the culture as a whole, it sort of became this, so the problem with quantum mechanics is there's many interpretations, and what Fritjof Capra and those guys did was said, they took one and said, well, that's what quantum mechanics says. And that's what you can never, ever do. There's like 10 different interpretations of quantum mechanics. You could probably come up with your own, and we have no idea which one of them is the valid one. So you can never say, oh, that's what quantum mechanics says, okay? So we have to find a way of now, sort of bringing this into the discussion while, sort of, trying to get the bad taste that physicists have in their mouth because of the Tao physics. All right, so to end, this is my last slide or so. The idea of the unspeakable. I think one of the difficulties here that we have to approach is we're talking about the unspeakable, the boundaries between the expressible and the inexpressible. Now, of course, poetry, art, music, myth, they've all been living here the whole time. And this is why this is also a push against scientism. Scientism says, the narratives that native peoples have about their relationship with, the landscape, it's got to be reduced to ecology. If it's not ecology, I don't care. But the point here is that no, there's many different kinds of things that are true and true in different ways. And so I particularly, I do koan practice. I've been doing it for a while. Every koan I get, I swear to God, I just stop and I have to laugh at my teachers. Okay, what's the new koan? Stop the sound of the distant temple bell. It's like, what are you talking about? What do you want me to do? Fine, hey buddy with the bell, shut up, The thing about koans is you don't, the answer is demonstrated, right? You have to demonstrate your answer. It's not like, it's not like a homework problem. And it's because it goes back to this idea of the unspeakable. There's things you can't, the problem with the blind spot is like anything you say about it is immediately wrong in some sense, because experience is this irreducible whole, and the words are just these, these things we've developed, this technique we've developed to wrap saran wrap around individual parts of it. So, how do you do this in philosophy and physics? I can see some ways how you can do this in philosophy of mind and such, but with physics, I still get stuck. I still get stuck wanting to have a reductionist kind of approach. So does all of this lead to a clear path to physics? Yes. No. Just kidding. There is no. I don't really know how. That's why I like to say yes. So we have a clear path forward to a new theory of quantum gravity from this. But I do think it could. I think there's a rich vein to be mined here in these discussions between neurophysicists, or not, neurobiologists, physicists, philosophers, contemplatives. So here's the ultimate question, and this is where I'll end. This is Stephen Hawking. What breathes fire into the equations? Right? So we've got these equations, which we think are the basal structures, right? But really, where's the luminosity come from that animates them? And so in some sense, it comes from us, right? Because of this realm of experience. So I will end there. Thank you very much.